Welcome to Arizona State University's Academic Success Program. This is an example video on chi-square.
What is chi-square?
Chi-square is a distribution. Chi-square is working with categorical data.
What is a categorical data?
This is data that is put in groups. It's like the data that is male or female. You have choices, but those are your only choices. There's no in between. There's no moving beyond one way or the other. Also, there is an hypothesis test that goes with it.
Are we going to be following the steps that was shown in the video hypothesis testing steps? Was there an example video that went along with that video too?
Yes, we are going to follow the steps in that video. And if you do not remember the steps, you can go and look at the videos too. Also, yes, there's an example video, and you can look at that for another example. The way this problem set up is a little different, but we still follow the same steps.
Okay, so can I share a problem with you and can we go over it?
Yes, we can. Before we do that, do you remember the steps we're going to go through?
The steps are 1. Read and understand the problem. 2. Figure out what test I know for this on is chi-square.
Yes, because we know what chapter and section we're working on. We know the test we're going to use, but for a test we might not know. Would be okay if we go over these steps in the discussion?
Yes, it'd be okay. I forgot the test might be one more than just chi-square.
Okay, what is step 3?
Label the hypothesis, for we know what we are testing. 4. The summary statistics. I would like to know this one by hand. I feel if I can do it by hand, I might understand it better.
I feel the same way. I can show you by hand. If you do not need to do it by hand on the test, please know how to do it the way your teacher wants you to do it. It will be a lifesaver, and knowing by hand might help you with explaining it on a test if you need to do that too.
Cool. Step 5 is calculate that test statistic. 6 is do a comparing method. In this case, because it is by hand, are we going to do the critical value method?
I believe so.
7. Write what we found in words. The last step and my favorite is to breath, because we did it.
That is great. What is your problem?
Okay, my problem is called M&M colors. Observing that the proportion of blue M&Ms in his bowl of candy appeared to be less than that of the other colors. Ronald D. Fricker, Jr., decided to compare the color distribution in randomly chosen bags of M&Ms to the theoretical distribution reported by M&M Mars Consumer Affairs. Fricker published his findings in the article The Mysterious Case of the Blue M&Ms Chance, Volume 9-4. pp. 19-22. There is a percentage table after this.
Good to know. I will have you share it with me in a little bit.
Can do. The problem keeps going. The following is the theoretical distribution. For his study, Fricker bought 3 bags of M&Ms from local stores and counted the number of each color in the 3 bags was distributed as followed. There is a frequency table.
Keep going and we will look at the second table later too.
Okay. Do the data provide sufficient evidence to conclude that the colors distribution of M&Ms differ from that reported by M&M Mars Consumer Affairs? Use alpha of 0.05.
Where did you get this problem from?
My sister's old stats book. This example is from Elementary Statistics Edition 7 by Neil A. Weiss. This problem is on page 552 and it is exercise 12.29. I wanted more problems to practice and to really start understanding it.
That is awesome. Can you please share the 2 different tables with me now?
Yes, here you go.
Thanks. Now for step 1 is read. I'm going to have Natural Reader reread the problem to us, where we both can listen and learn all we can from the problem. and know what's asking and what is being told.
Observing that the proportion of blue M&Ms in his bowl of candy appeared to be less than that of the other colors, Ronald D. Fricker, Jr., decided to compare the color distribution in randomly chosen bags of M&Ms to the theoretical distribution reported by M&M Mars Consumer Affairs. Fricker published his findings in the article, The Mysterious Case of the Blue M&Ms Chance, Volume 9-4, pp.19-22. The following is the theoretical distribution. For his study, Fricker bought 3 bags of M&Ms from local stores and counted the number of each color in the 3 bags was distributed as followed. Do the data provide sufficient evidence to conclude that the colors distribution of M&Ms differ from that reported by M&M Mars Consumer Affairs? Use alpha 5.05.
What are you understanding in this problem?
I am understanding that we want to test to see if the expected amount of each color of M&Ms is being observed.
Good, that is what I'm getting from the problem too. Now for step 2. What tests are we using? Even though we know it is a chi-square, let's ask the questions to ourselves for we can see what we should be looking for when we're taking a test.
We can do.
Great, and do you remember what the 4 questions are?
I think I do. The first one is what you looking at. Second one is are you comparing data? Number 3 is what are you working with? The last one is what tail test are you doing?
That is awesome. Good job. Now let's go into more detail with each question. 1. What are we looking at? Is it proportion? Is it mean or what?
It is row.
Honestly, I am not sure. I am not an expert on everything. When I do this problem in the past, I write out the hypothesis in words and not in symbols.
Okay, so if not sure on symbol, write out in words what I am wanting the hypothesis to be.
I would say yes. Remember, you still need to figure out what test to use.
Can do. And is this a goodness of fitness test?
Very close, but it's fit, not fitness, so goodness of fit test. Number 2, are you comparing data?
No, because we are not working with 2 different data sets, just one.
Correct. What are we working with?
Has it one table, so I will be using that table.
Yes, it has its own chi-square table you will be using. Number 4, what tail test?
It is left tail test.
No, I believe that a chi-square is only a right tail test. Do you feel ready for a test to this point? If you see a question like this on it?
I think so. Now, step 3 is set the hypothesis.
Correct. So, what do you think they are?
The null would be that the expected numbers of colors of M&Ms are the same as the observed. The alternate would be that the expected numbers of colors of M&Ms are not the same as the observed.
Yes.
You say in the other videos to do the alternate first, but I did not. Am I still correct?
Yes, you are correct. In the other videos, I suggest to do the alternate first, but you don't need to. Do what feels more comfortable to you. Either way, you should come out with the same hypothesis, no matter which one you figure out first. So, step 4, right?
No, we first need to have the alpha number written down for we do not forget.
Correct. And what would that be?
According to the problem, alpha is 0.05.
Awesome. Let's keep going. Step 4, summary statistics.
So, I think I need to create another table.
Okay, we can do that. How would you like to do this?
I think we should have the colors for the column, and for the rows, have the expected percentage, what we observed and what we expected to observe.
How would that look? Please make me a table.
This is what I think the table should look like.
Okay, why did you do a total column?
Because I wanted to make sure the percentage was equal to 100, and I feel that I need to know the total number of M&Ms that was counted. I am a little lost on the bottom row. Can you please explain it?
Yes, I can. The bottom row is a number we should be seeing out of all the MMs we counted. So, how do you think we'll calculate it?
We do the expected percentage multiplied by the total number that we counted for each color. Is this right?
Yes, it is. Please finish filling out the table.
Brown is 152.7, and I did 509 times 0.3. Was that right?
Yes, it is. I would not round, but you might get decimals, and that's okay.
Yellow and red is 101.8. Orange, green and blue is 50.9. And I checked to see if I would get 509 as the total still. I still did.
You did great. And that is all we need to do for summary statistics. Step 5. Test statistic. What do you think the formula we are using for our test is going to be?
I think it is the sum of observed expected squared all divided by the expected. And the sum means we do it for each color and then add them up.
Correct. And how would that look like?
To not mix up my steps, I am making a table. The test statistic is 4.09, based on the math I did on the table.
I liked how you organized the table, with each column being its own step. Good job. And your answer looks good for me. The next step is comparing method.
I like using the p-value, but sometimes my teacher says to use the critical value instead. Can we do the critical value today?
Yes, we can. What do you think we need to do first with this method?
We need to find the critical number on the table, and we need the alpha and the degrees of freedom. And I know I have alpha of 0.05 and degrees of freedom is 6.
Very close. Your alpha is correct. But the degrees of freedom, it is k minus 1. So what we would be doing is 6 minus 1, and that would be 5. And when we look at the table, we will find...
I will find the critical value is 11.070. This tells us we failed to reject the null.
Sounds good. And the step before the last step, step 7. Write what we found in words.
I think I should say this. There is not enough information to show that the expected percentage of colors of M&Ms is off.
Awesome!
Now, the last step is B, because we did it.
Correct. Now how are you feeling?
I think I need more practice. But I need to remember to take my time and follow the steps of hypothesis testing. I think I was trying to rush the process.
Good about reflecting on what you were doing differently before and this time. I agree to take your time and breathe. You can do it. Do not stress out about it.
Thanks.
You are welcome. Thanks for coming and talking about chi-square with me.